Hi, and welcome to this review of percentages. As with most math concepts, the terminology that is used often holds the key to truly understanding the big idea. We're going to cover some basic skills to help you translate the language of math so you can grasp the concept of percentages easily after a little practice. Let's start with the basics. What exactly is a percentage? This can be answered by reviewing the concepts of fractions and place value. A fraction is considered a part of a whole. When dealing with percentages, the whole is 100. 48 out of 100. The fraction 48 out of 100 is read as 48 100ths. The division of 48 by 100 results in the decimal value of 0.48. Note that the decimal place in the whole number, 48, is moved 2 places to the left. Here is when the review of place value comes in. For numbers expressed as decimals, the places to the right of the decimal point describe the fraction of the next whole number. As you can see here, the first place to the right of the decimal point is the tenths place. The second place to the right of the decimal point is the hundredths place, which is what determines the percentage. A percentage tells us how many hundredths of the next whole number are represented. To convert a decimal value to a percent, simply move the decimal point 2 places to the right and be sure to use the percentage notation. Of course, there are situations when a percentage must be rounded to a particular place value. We will cover that idea in the following examples. Let's take a minute to apply this information to the effect of the flu. Let's say there have been approximately 16,337 people affected out of the 214,589 people who have been tested for the virus. This fraction, 16,337 over 214,589, converts to the decimal 0.07613. We will convert this decimal to a percentage by moving the decimal point 2 places to the right and rounding the percentage to the nearest tenth. This gives us 7.6%. This tells us that out of all the people tested, 7.6% of the tests have been positive. With this information, we can learn even more about the effects of the virus. Let's say that 95% of the people who tested positive for the flu recover. Typically, this high percentage is enough to know that most have recovered, but we can determine the actual number by simply multiplying the decimal equivalent of 95% by the number of people who tested positive. Step 1. Convert the percent to a decimal by moving the decimal point 2 places to the left. So if we have our 95%, we want to move the decimal place 2 points to the left, and that gives us 0.95. Step 2. Multiply 0.95 by the number of people who tested positive for the flu virus. 0.95 times 16,337. This gives us 15,520. So the good news is that 15,520 people who tested positive made a full recovery. As you can see, this work involves the operations of multiplication and division. The wording of the problem will let you know which operation to use. When asked to find a percentage, you will often notice the phrase out of, as shown in the first example. In the second example, the percentage of recovered flu patients is known, and the word of indicates the use of multiplication to determine the actual number. The percent here, in decimal form, is multiplied by what is called the base value. There will be times when you have the information for a straightforward multiplication problem, like the one in our second example. Other times you will have to solve for the unknown percentage by dividing both sides of the equation by the base. Let's move on with an example of a division problem. Unfortunately, in this hypothetical flu breakout, there also have been 894 deaths. What is the percentage of deaths to those who have tested positive? This time the equation has the number of deaths that resulted from the positive test cases. We will have to solve for the unknown percentage by dividing both sides of the equation by 16,337. 894 over 16,337 is the same as saying the percentage of the whole, which is 16,337, over the whole, or 894 over 16,337 is equal to our percentage. The decimal equivalent of the fraction is 0.00575. Note that the value in the hundredths place is 0, which indicates that the percentage will be moving less than 1%. Moving the decimal point 2 places to the right results in this. 0.575%. At this point, you will have to determine how precisely you want to represent the percentage. Showing more decimal places is more accurate, but it is often not necessary to show more than one decimal in a percentage. Because the 7 in the next decimal place is greater than 5, the percentage is rounded up to 0.6%. The ability to process data like this is helpful to see the big picture. News of large increasing numbers and spikes of flu cases can be frightening, but relating the numbers correctly is necessary to gain insight to patterns and trends in the data that are available. 7.6% of the flu tests were positive. 95% of the positive cases recovered. And 0.6% of the positive cases resulted in death. And hopefully, 4.4% of the positive cases are in the process of recovering. Let's move on with a few more examples of calculating and finding percentages of values. In a group of 169,000 people, 76.5% of them prefer apples over bananas. How many people prefer apples? This is a straightforward case of multiplication using the equation value equals percent of base. Step 1. Convert the percentage to decimal form. We do this by moving our decimal point 2 places to the left, which gives us 0.765. Step 2. Multiply by the base, which is 169,000. 0.765 times 169,000. This gives us 129,285. In our group of 169,000 people, 129,285 of them prefer apples over bananas. Here's an example that you may be familiar with. When dining out, people usually leave a tip for the waitstaff, averaging between 15% and 20%. Depending on the quality of service. Mike was so happy with his service that he left a $20 tip on a bill that totaled $82. What percentage was the $20 tip? This time the template will look like this. Tip equals percent of bill. So 20 equals the percent of 82. Solve for the percent by dividing both sides of the equation by 82. Like this. This gives us that our percentage is equal to 20 over 82. This calculation results in a decimal value of 0.2439. Moving the decimal point 2 places to the right and rounding to the nearest percent results in a generous tip of 24%. For our last two examples, I want you to try to figure out the answer on your own. The next time Mike went out for dinner with his friend, the service was terrible. Their waiter rarely attended to their table and they waited over an hour for the food to arrive after ordering. Mike decided to leave a 12% tip on the bill totaling $76. How much will Mike leave for the tip? Pause the video now and see if you can figure it out. Let's check your answer. If we use our tip equation from earlier, we get that the tip is equal to 12% of the $76. This translates to multiplication. So our tip is equal to 12%, which when we turn it into a decimal, we move our decimal 2 places to the left, and we're left with 0.12 times $76, which equals $9.12. So the 12% tip on the $76 bill was $9.12. Here's our last example. Last week, a popular restaurant with a seating capacity of 120 people only had 38 customers in the building at the busiest time of the day. What percent of 120 is 38? Pause the video and see if you can solve it. Let's see if you're right. Use the equation 38 equals the percentage of 120. In this problem, solve for percent by dividing both sides of the equation by 120, like this. 38 equals our percent of 120 divided by 120 gives us that our percentage is equal to 38 over 120. When we turn this into a decimal, we get that our percentage is equal to 0.3166. If we round to the nearest tenth, they were only at 32% of capacity at the busiest time of the day. $38 customers equals 32% of the total capacity of the restaurant. That's all there is to it. As you can see, it is important to know how to calculate percentages so we can put data into proper perspective and create statistics that make sense. I hope this review is helpful. Thanks for watching and happy studying.